Alright, this is going to be the Chapter 8 Learning Target number 5 video. So right here is your learning target that we're going to be covering. You'll remember solving one-step equations was before Park, plotting inequalities on a number line, writing inequalities from real-world situations, and solving inequalities were the first four targets, and we just kind of put this on pause until right now. So learning target number 5 is I can solve problems involving equations and inequalities in real-world situations. So you're going to, you're going to solve these problems, these equations. So you're going to do what you did for learning targets 1 and 4, only now they're going to be in the real-world setting. So you may even have to write these inequalities or equations from real-world situations. So it's kind of like numbers 1, 3, and 4 kind of put together into one big part. So go ahead and flip to, I'm not even sure what page this would be, but it should say learning target number 5 at the top. Mine's kind of hard to see, I apologize. Once again, there's your learning target up there, being able to solve problems involving equations and inequalities. So here we go. Yesterday, Kyle had some food stamps. Today, his father gave him 12 more stamps. Now he has 27 stamps altogether. Okay, so how many stamps did Kyle have yesterday? Now this is where the variable comes in, because again, we use variables in the situation for unknown numbers. Okay, and right here's the first sentence, and that's what they did. They broke it like this, and you can see some stamps would be an unknown. We don't know. That's what we're looking for. And then we know that today, right here, his father gave him 12 more, so having 12 more would be adding 12 to whatever he had before. And then we know that he has exactly 27 after that, what he had and his dad gave him, and there's where we got 27. So you're kind of writing the equation, and then you're going to solve it as well. I know this looks maybe a little bit different than we would have done it. I'll show you the way we would have done it. Remember, we would go like this, and then we would draw a line separating the left and the right side of the equal sign. Then we ask ourselves, what is happening to the variable? Well, 12 is being added to it, so we need to undo that by subtracting by 12. And we find out that x equals 15, which makes perfect sense, because if you go up in here and you said Kyle had, and instead of it saying sum, and you said Kyle had 15 stamps and his dad gave him 12 more, well, if he had 15 and his dad gave him 12, wouldn't he have 27 total? So that's kind of like we checked ourselves on that. Okay, go down to the next question here. In a pond, there are 3 times as many koi as goldfish. If there are 48 koi, find the number of goldfish in the pond. So here we go. In a pond, there are 3 times as many koi as goldfish. Okay, which means we do not know the number of goldfish there are. We just know that there's 3 times that amount. So in this case, our goldfish is going to be the variable. Okay, and since there are 3 times as many koi, that's going to be times 3, and then we know that there are 48 koi. So that's where that comes from. So it makes perfect sense. Now we wouldn't write it like this. We all know that we would write it as 3g equals 48. And then we ask ourselves, what is happening to the variable? And all of you would say, it is being multiplied by 3, so we're going to divide it by 3 to both the left and the right. We're going to be left with g equaling 16. Then again, we just come up here and we ask ourselves, does that make sense? Could there be 16 goldfish? And you say, okay, if there are 3 times as much as this, of that, then we should be able to do 3 times that and get us the actual number of koi, which it does give us that. Okay? Go ahead and go to the next page. Oh, and here's the work for that one. So we already did it though. Okay? On Monday, Wendy had some leaves in a collection she was making for biology class. So whenever you see that word, some leaves, or an unknown amount of any kind, I already start thinking, okay, I'm going to use a variable. Now I kind of peek down here and I see that it wants me to let R represent the variable for the amount of leaves. Okay? After she collected 23 more leaves on Tuesday, she had 41 total leaves. Okay? So right away, we're kind of piecing this whole thing together. And like they did on the examples that I just did, you can see that the amount of on Monday, we don't know how many leaves she had. We call that R. And then on Tuesday, we know that she gained 23 more. So we're adding 23 to whatever she had to begin with. And then we know that on Tuesday also, we know that she had combined, she had 41. So we know this is going to equal 41. So right there's your equation. We just broke it down with all the pieces we knew, and you can see that, you can follow that if you'd like, but I just like to write it like this: R plus 23. We know that 23 is being added to R, so we're going to subtract 23 from both sides. Okay, and we're going to find that R is going to equal 18. And then just ask yourself real quick, does that make sense? Okay, instead of this being in there, let's say Wendy had 18 leaves in her collection. After she collected 23 more Tuesday, she had 41. So what we're basically seeing here is that that's how much she had Monday, that's how much more she collected on Tuesday. So we know that this is going to be 18 plus 23, and it better give us 41 because that's how many she had once she ended. Okay? Here's some practice questions. I'm going to pause this, and I would like everybody to try these. Let's just do 2 at a time. So I just want you to try number 2 and number 3. Okay? Carlos thinks of a number. When he adds 17 to it, the result is 45. What is the number that Carlos thought of? So again, here's your unknown. He thinks of a number. We don't know what that number is. Whenever we don't know what a number is, we automatically give it a variable. Okay, and I'm going to call it X. Okay, I'll just call it X. You could have called it whatever variable you'd like. Okay, but I know that what it's saying is I have X, and when I add 17 to it, the result, which is what it equals, is 45. So you must solve that now. We're going to subtract 17 from both sides. And I didn't leave you really enough space here, but you know that it would be X is going to be equaling, that's 17. And then 45 minus 17, we'll go ahead and just work it out up here. Borrow from the tens place. Whoops. 15 minus 7 is 8. 3 minus 1 is 28. Okay. So check it out. Let's just plug it in here. Let's, instead of it saying of a number, let's say Carlos thinks of 28. If you take 28 and you add 17, it had better give you 45, and it does. So we checked ourselves. But the work here I'd be looking for when it comes test time or when you're doing the practice, that's the equation I would need you to write. I would need to see you solving the equation and then obviously finding that answer. Okay? Sylvia bought some blouses and t-shirts. Again, we don't know that. That's our unknown. So give it a variable. We'll just say B for blouses. Even though it's t-shirts also, combined, they are blouses and t-shirts. Okay? She paid a total of $63. The t-shirts cost $29. How much did the blouses cost? Okay, well, we know that when you really think about this, what you're really thinking about doing is you're saying, well, I'm going to call, and I probably shouldn't have called this B, probably should call it T, because we're really going to be looking for the t-shirt. That's the unknown. So we know this is going to be really blouses plus t-shirts equals $63. Okay? Now, obviously, if that's what we had as an equation, you wouldn't be able to solve this because you don't know one of the two. You can't have two variables and solve. So that's where you got to be a good reader and you got to see, oh, the t-shirts cost $29. So that means the t-shirts, you're going to put in 29 in there for T, and then really what you're doing is you're doing the blouses plus 29 equals 63. Everybody see how I did that? And I think I messed up this variable earlier too, so I apologize for that. But regardless, it's the amount of however much you spent on blouses and t-shirts added together to get $63. So now solving is the easy part for you guys now because we've already done it in learning target number 1. We're going to subtract 29 from both sides, and we're going to find that B or the amount that was spent on blouses, which is B, is going to be, and you can do your subtraction right here, and you don't have to rewrite it every time, and you're going to get 4, and 5 minus 2 is 3, and you're saying that you spent $34 on blouses. Just to make sure, let's do 34 plus 29, just to make sure, and that's going to be $63, which is what we said it should be. So right there would be our answer. Okay. Let's go ahead and pause and try the next, number 4 and 5. Go ahead and try these now. Okay. Felicia used 153 yellow beads and some green beads for her art project. She used 9 times as many yellow beads as green beads. Sounds like I'm saying green beans. How many green beads did she use for the project? So this is in a little bit different order. This one may throw you, or may have thrown you a little bit, because you know, all these other ones have given you the parts of the addition problem and then given you the whatever it equals at the end of this problem. Okay? Okay, so this one is a little bit different because it's actually giving you kind of the total to begin with here. Okay, so it says 153 yellow beads and then some green beads. So again, whenever you see that sum amount, we don't know that amount, we'll go ahead and just we'll say G for green beads. Okay, so we got these numbers. Try to put them all into place here in a minute. So she used 153 yellows, and we don't know how many greens. She used 9 times as many yellow beads as green beads. Green beads. How many green beads did she use for her project? So let's think about what would make sense here. We know this is going to be 9, and we know we're taking 9, if you think about it, and we're multiplying it. We're multiplying the number of green beads by 9 because she used 9 times as many. So we're going to do 9G equaling 153, right? Because she used 9 times as many of these yellows as greens. So now we're ready to solve, okay? And we learned that G is being multiplied by 9, so we're going to divide by 9, and I'll use my calculator on this one to save a little bit of time. We got 153 divided by 9 is 17. So we know that she used 17 green beads. So she used a lot more of the green beads than she did, flip that. She used a lot more yellow beads than greens. And specifically, she used 9 times as many yellows as greens. Ivan had saved some quarters. He spent 50 quarters, which was 2/5. Maybe some of this got cut off. Okay, I apologize. I guess this one got cut off, so let's not even worry about it. I don't exactly know what happened to it in your notes, so we'll just move on. Okay, now, next section here. Now, we're going to go a step further with this, and quite frankly, this is a little bit more challenging than the writing algebraic equations. Now we're going to write algebraic inequalities to solve real-world problems. These are difficult. Okay. Jamal sees the sign shown in a store window. He sees a sale. All t-shirts cost less than $16. Okay. You're going to write an inequality to represent that situation. Use a number line to represent the inequality, then give the greatest possible cost of a t-shirt. Okay. So, the all t-shirts cost, like they have here, right there in red, that's going to be our variable. Because we don't know how much the t-shirts can cost. They can cost $1, $2, $5, or whatever. Okay, and that's the whole point of the inequality, because there's not just one amount. There's not just one number that could be put in for that variable. There are a lot. Okay, so when you get it, you figure out that the inequality is C less than 16, which makes perfect sense because we know the cost of each shirt, or all shirts, has to be less than $16 that is said. Okay, so obviously they already graphed it for you here. It would be an open dot on 16, and then we would shade everything to the left because, again, we're talking about all shirts being less than $16. Now, if we're talking about if I asked you, if this had nothing to do with money, it was just C less than 16, and I asked you what the largest possible number to go in there for C, you would not be able to answer that question because you could say it could go on forever. 15.9999999 and so on. Forever. Infinite, right? We talked about that. Okay? But because we are specifically talking about money, and our money system only goes to dimes and pennies, we know that that's the cutoff. So the greatest possible cost of one t-shirt would be $15.99. Okay, that's key to know. So if it would have said all t-shirts are $16 or less, then $16 there could be a shirt that was 16, but it specifically says all shirts less than 16, therefore $15.99 would be the smallest amount of money for a t-shirt for this particular sale. Okay? Let's look at the next one here. Okay, a ski club is organizing a trip. At least 20 members, at least 20 club members have to sign up for the trip to cover the cost of the bus. Now I'm just going to tell you right now, I'm going to highlight this word. This is a buzzword right here for inequalities. And we can write a couple of these. At least, write these. We already have it there. At most. Okay, obviously less than. Greater than. Okay, maximum, minimum, and more will come to me as we go here. But these are the words that really speak inequality, because it's saying, okay, I have to have at least $20. So that would mean I could have more than 20, but I could have exactly 20. I could have $20.01, $20.02, $28. Okay, I have to have at least that. At most would be the opposite of that. Okay, so we've got to know those words. So know those words. Buzz words. Okay? All right, so going back to the question. At least 20 club members have to sign up for the trip to cover the cost of the bus. Write an inequality to represent the situation. Then draw a number line and let W... use a number line to represent the inequality. Let W represent the number of members who sign up for the trip. So as you can see, we do not know how many people are going to sign up for the trip. All we know is that we need at least 20 so that it's paid for, so it's covered. Okay? So that's why this would actually be a greater than. People get confused because they see at least and they think, oh, that must be a less than. No. At least would mean there has to be at least 20. Which means 20 members could come and they're good. 21 members could come, that's good. 22 and so on. And we could go all the way up to, get bigger from there. Okay, so you can see they used a closed dot because it's an or equal to. They shaded to the right because, obvious reasons, we have to have at least that amount right there, but anything else, we're all good. Okay? So obviously, the least amount of people they would need would be absolutely, just as long as they get 20, they're good to go. Okay. Let's go up and do one more together, and then maybe I'll have you guys practice some. The figure shows a speed limit sign on a highway. Okay, so there's our speed limit. Let X represent the speed in miles per hour. Write an inequality to represent this situation. Okay. Well, if X is the speed, and I know that we're dealing with 55 miles per hour. That's the speed limit. Okay? So, you're a driver. You got to put yourself in the minds of you have a car and you have a license. Think about this. Is it okay to go 56 miles an hour? No. Is it okay to go 57? No. 58? No. 74? No. Okay? Is it okay to go 55? Yes, of course it is. That's great. You can go right at the speed limit. So right there, that keys you in onto the fact that it's an or equal to. Now, can I go 54? Sure, you can always go under the speed limit. You're going to annoy everybody around you, but you can always go the speed limit or under it. 53, and then 52, 51, all the way down to 0, I guess. Okay? So here's the thing. What's going to be the inequality that represents it? Is it going to be less than or equal to or greater than or equal to? Hopefully you're all thinking less than or equal to. Okay? And that would make all of these right here would make X a true statement here. Okay? Given the maximum legal driving speed on a highway, the maximum legal driving speed is, okay, I guess 55 miles per hour. I don't really know what we were trying to do there. Regardless, this was the important part, just being able to do it. You don't have to graph it or anything. If we graphed it, it would be a closed dot on 55 with the shading going to the left of 55. Okay, I would like to pause and I would like you to go ahead and try number 7, please. 7 only, A and B. Go ahead. Okay, more than 35 guests came to Katrina's birthday party last Sunday. So we're going to let X be her guests. How many guests she had. We do not know how many guests that came to her party. So we give it the variable. So we're going to put X in there. We know that the number 35 was given. Now what we got to determine is, okay, how many could she have had? Could she have 35 exactly, based on what we're seeing here? Could she have 35 people at her party? No, because it specifically says more than 35. It would have been a different story if it said 35 or more. It says more than 35. So that means it has to be 36 people could have come, absolutely. 37 people could have come, 38 could have come, 39, and so on. So this is going to be X greater than, because all of these make that true. So what is the least number of guests who could have come to the party? A lot of people would say 35, guys, but that is wrong because it specifically says more than 35. So the least number of guests she had was 36. She either had 36 or more. You could also say it that way. Let's go ahead and do number 8 together. In Mr. Boyle's class, the students are required to summarize a passage in less than 50 words. Write an inequality. So you have to summarize it in so many words. We do not know how many words they used. So I'm going to give that the X. Then I know that it says right here they have to do it in less than 50 words. Now that makes it kind of easy when you see less than, because it's kind of like, you know, it's easy because you guys know that's a less than symbol. But again, don't just assume. Actually go in here and check and ask yourself, could they do it in 60 words? Is that okay? No. That's more than 50. You could not do that. Could they do it in 70? No. Could they do it in 40? Yes. Could they do it in 49? Yes. But here's the real question. Can they do it in 50? And the answer to that would be no. You cannot do it in 50 words because it specifically says it has to be done in less than 50 words. So this would not be an or equal to. So what is the maximum number of words that a student can use? It would be 49. Okay? All right, let's go ahead and look at this last one, possibly. Okay. A cargo elevator has a load limit of 240 tons. I guess this isn't really one of those buzzwords we talked about, but we're going to let X represent the load limit of the inequality, and we're going to write this inequality. So X is how much weight that elevator can handle, and 240 was given as a constant number there. Okay, so we got to ask ourselves, could I put 241 pounds in that elevator? No, because its limit is 240. So could I put 239? Absolutely, because I just can't go over 240. So I know this has got to be less than. Now here's the magic question though, the one that gets everybody. Could I have exactly 240 tons? That answer would be absolutely yes, because the limit is that, which means you can go up to that, but you cannot go over it. Therefore, this would be a less than or equal to. And what is the greatest possible load? It would be 240 tons. Okay? And we're going to go ahead and stop there because this has been long enough. We'll do these maybe on a warm-up eventually here, but we'll stop there.